Hello everybody, welcome back to Decode ISC. In the previous video, we saw how to easily solve sum of product expressions, and in this video, we're going to focus on product of sums. Let's get started. Before drawing the grid, we need to remember a couple of differences between POS and SOP. Now, there are three main differences that we're going to focus on. The first one is that we completely and entirely focus only at zeros, not ones. We will place and group zeros in the grid. The second difference that we need to remember is that POS deals with max terms, and that is denoted by the symbol pi. SOP deals with min terms, and that is denoted by the symbol sigma. Okay, the third and the most important one is the change in logic. Now, if you look at this table carefully over here, what you notice is that in SOP, the meaning of 0 is complemented form A dash, and the meaning of 1 is normal form A, right? This thing completely inverts for a POS. Meaning of 0 becomes the normal form A, and meaning of 1 becomes the complemented form A dash. Now, here's what we need to remember in this aspect is when you're writing, say, a binary number 0, 1. If you're writing for SOP, how do you write this? A dash B, correct? But in the case of a POS expression, we write it as it's A. 0 is the normal form A, and 1 is the complemented form. So plus, because it's product of sum, plus 1, that is B dash. So this is the very big difference between SOP and POS. Moving on to the rules of grouping. So it's the exact same rules of SOP, whatever we've learned in the previous video, but only difference is instead of grouping ones, we group zeros. Now, how do we fill the K-map? Now, if you remember the gray code, how did it go? 0, 0, 0, 1, 1, 1, 1, 0. So obviously over here we're placing our variables A, B, and here C, D as well. And then again 0, 0, 0, 1, 1, 1, 1, 0. Now, how do I write this in binary form? This is going to be A plus B, because 0 denotes in POS, 0 denotes the normal form. Similarly, this is going to be A plus B dash. This is going to be A dash plus B dash. And this is going to be A dash plus B. Right, we can do the exact same thing over here. This is C plus D, C plus D dash, C dash plus D dash, and C dash plus D. The numbering of the cells remain the same as it was in SOP. Now let's move on to a very quick example just to collect everything that we've learned. So again, as I said, we denote POS by the symbol sigma. So we place a corresponding 0 to every number that is over here. So 1, 0, 3, 0, then 5, 7, 9, 11, 13, and 15. Perfect. In the remaining boxes, we fill them up with a 1, the opposite of what we did with an SOP. Now, when it comes to grouping, what do? We group all of the zeros, correct? So if you remember, the priority order goes as octets first, and then quads, and then pairs. Now, in this particular example, is only one group that we can create, and that's this octet group. Okay, now let's move on to the next part, how to simplify these expressions. Now, if you remember, as we learned in SOP, octets would eliminate 3 variables, and then we have quads that eliminate 2 variables, and pairs that eliminate just 1 variable, right? So that's important that you remember that. Now, how do we do the simplification part? So we're going to find, or we're going to express each of these cells in Boolean expression form, right? So this one is going to be A plus B plus C plus D dash, right? The other one's going to be 3. This one's going to be A plus B plus C dash plus D dash. Now do that for 5. That is A plus B dash plus C plus D dash. Then 7 is going to be A plus B dash plus C dash plus D dash. Now 9 is going to be A dash plus B plus C plus D dash. 11 is going to be A dash plus B plus C dash plus D dash. And then 13 is going to be A dash plus B dash plus C plus D dash. And 15 is going to be A dash plus B dash plus C dash plus D dash. Now if you remember the same thing that we did in the SOP, we're going to find any two pairs and eliminate the complements. So if we take these two, we can eliminate C and C dash. And now if you take these two, we can eliminate C and C dash again, the next pair as well. Now you can take any other pair, say this and this, right? We eliminate A and A dash. Similarly over here and here and here. Correct. Then we can take say this and this. What can we eliminate there? D dash. Then this and this. This and this. B dash. This and this. This one here and this one here. B dash. Similarly over here as well. So what are we left with? We're left with D dash, right? So because this is an octet, we have eliminated 3 variables to give our final expression D dash. And that is all for this video. Thank you so much for joining, and I'll see you in the next one.